All right, this is video number 4 in the middle of the page on page 591. We are going to be learning how to find the area of a rhombus and a kite. You may or may not have done that before, but let's look at it. A kite or a rhombus, actually I'm going to show you the pictures while I read it. A kite or a rhombus with diagonals D1 and D2, so this would be like D1 and D2 would be the one going in that direction all the way. A kite or rhombus with diagonals D1 and D2 can be divided into two congruent triangles. Here we have one on the top, one big triangle, and one big one on the bottom. Same down here. And those triangles each have a base of D1. Do you see that D1 is the base of this top triangle? And if we flipped this one over, it would be the base of it as well. And they each have a height of half of D2 because diagonal 2 would be running all the way through. So the height of this top triangle is just half of D2. The kite is working the exact same way. You can apply everything I just said to it. So if we look at this, if we were finding the area of this top triangle, of course it would be area equals 1/2 base times height. But it's not quite that simple because of all these fractions that we're dealing with and these variables. So let's look at what they've said. The area of each triangle, or just like this top triangle for example, is going to be 1/2, there's our 1/2, like 1/2 base times height. And then our base, which is D1, you can still see it in the picture, times our height. Our height is half of D2. Remember, D2 should be running all the way. So using our triangle formula, half base times height, we have 1/2 times the base, which is D1, times the height. Then all of this is the height. When we multiply that together, 1/2 times 1/2 is 1/4. So the area here is 1/4 D1, D2. Diagonal 1, diagonal 2. Okay, now let's look at, sorry, there it goes. I'm trying to move the phone uphill on the page. I apologize. Okay, now let's look at finding the total area. So not just the area of that upper triangle, but the area of that whole rhombus or the whole kite. So this time we need to say 2 times that triangle because we only found half the rhombus. So we're going to say 2 times our answer for the area of the triangle, which was 1/4, diagonal 1 times diagonal 2. Now to simplify this, we need to say 2 times the 1/4. So 2 times 1 is 2. We can treat this 2 like it has a 1 on the bottom. So 2/1 times 1/4 is going to be 2/4, which simplifies to 1/2. So our simplified total area formula for a rhombus and a kite is 1/2 D1 or diagonal 1 times diagonal 2. All right, let's look at it. Area equals, or total area equals 1/2 times diagonal 1 times diagonal 2. So that should be pretty easy for us to apply now. That's simply what's written right here in this Note It section. And now we will go ahead and start on the exercises. Find each measurement. This is example 3 at the bottom of 591. Find each measurement of rhombuses and kites. So in letter A, we are asked to find D2 of a kite in which D1 is 16 and A is 48. Well, let's cheat a little bit. Not really. We really absolutely are not going to cheat. But we are going to borrow this diagram that's already done. And we're going to call D1 16. And we're going to say the area is 48. Now let's go plug those things into our formula. Our formula for the rhombus and kite is 1/2 diagonal 1 times diagonal 2. And we're going to solve for diagonal 2. So for our area, we're going to plug in 48. And then we keep our 1/2 that is part of the formula. And then remember they told us that D1 was 16. So we've plugged that in. And we leave D2 as the variable that we're solving for. Now we can say 1/2 of 16 is 8. And then we can divide both sides by 8. And 48 divided by 8 is 6 equals D squared. I'm sorry, this is not a D squared. This is D2. I apologize. I may do that other times in this lesson, and y'all may just have to overlook it if I don't catch it. So 6 equals diagonal 2. That's it. That's the end. That's what we were asked to solve for. So in our diagram, We had one that was 16, one diagonal, and one that was 6. Okay, let's flip over, and I will try not to drop the phone. This is our last page, and it will take us 2 videos to get through it, but the last one will not be very long. All right, now we're going to use the exact same thing to find the area of a rhombus. So in this rhombus, we are given our 2 diagonals. We're given 6x plus 4 as one diagonal, and 10x plus 10 as the other diagonal. So this will require some algebra, but otherwise should be pretty easy. Let's go plug those diagonals into our formula that says for the area of a rhombus, area equals half diagonal 1 times diagonal 2. So we are going to start plugging things in on the second line. Area equals 1/2. Diagonal 1 is 6x plus 4 times diagonal 2, which is 10x plus 10. Now, think through how you're going to put this together. We are going to FOIL. So I'm going to write the letters so you see them and can practice first, outer, inner, last. So our first is 6x times 10x. That's going to be 60x squared. Our outer is 6x times 10, which is 60x. Our inner is 4 times 10, which is 40x. So 60x plus 40x gives us our middle term, which is 100x. And then lastly, we have 4 times 10, which is 40. So now our area tells us 1/2 times this trinomial. We're simply going to distribute the 1/2 to the rest of the problem, and area equals 30x squared plus 50x plus 20 inches squared. That's as far as we can go in that problem. We cannot solve for these x's. We're solving for area, and there's nothing over here for us to do an equation to be solving for these variables. So that is our answer to area for this rhombus. All right, let's look at B, the area of the kite. We know that the area of the kite formula is 1/2 diagonal 1 times diagonal 2. But let's look at what we have in this kite. Actually, before we do, I need to erase all the answers that I stuck in there when I was working through the problem. There we go. Okay, we are given 41. We're given the top half of this diagonal, which is 9, and we're given 15. Let's plug in the rest of those pieces. 15, 9, 41 feet. Okay, now we can do some serious solving. Problem is we don't know both diagonals. We know one is 18, 9 plus 9, but we don't know what this one is, so we're going to have to solve for it. Because we have all these pieces of the puzzle, we can be using the Pythagorean theorem here. So let's use it to solve for this part of the second diagonal, that part right there. So we're going to say 9 squared plus x squared, as you will see, you can follow along right here, equals 41 squared. And then 41 squared divided by 9 squared equals 1,600. Now we need to take the square root of it, and we get 40. So this part of our diagonal is 40. Now we've got to find this part. That's going to be simple for you. We're going to say 9 squared plus y squared equals 15 squared. Here's the Pythagorean theorem worked out. Y is going to equal 12, and I'll move it back over so you can see. So now we can find the area of this kite because now we have the lengths of both diagonals. But don't forget, we're going to have to add the parts. So one length is going to be 40 plus 12, which is 52, and the other one's going to be 9 plus 9, which is 18. So see if you can come up with the formula on your own. Area of a kite or a rhombus equals 1/2 times diagonal 1 times diagonal 2. So we're going to have 1/2 times 52 times 18, and that equals 468 feet squared. All right, I'm just going to hover over Check It Out 3 for a minute in case you are struggling with this. There's my work for it and solving it. That will allow you, if you need to practice it, to work through it and then come back and check your work. Okay, the last video will be number 5, I think. I hope I'm right about that, and it shouldn't take long.